Hi guys, this is Dr. Diaz again, torturing you now with complex numbers. And if you remember, if you had look at the chapter 8 earlier, or at the end of chapter 8, we discussed, there's a section that talks about complex numbers. You know, there's the real numbers, the numbers we know, has whole numbers, integers, natural numbers, rationals, irrational, e and pi. There's another group of numbers, the complex number, and those are the ones that you have seen. If you use your calculator, try to calculate, for example, the square root of -1. If you use your calculator, it's going to tell you this error. But in reality, it's a number. It's not a real number. It's a complex number, and we call it I. And there's some kind of a sequence that I uses, like I. You can call it I is equal to I squared is equal to -1, I cubed is equal to -I, and I to the fourth is equal to +1. And the cycle is repeated every fourth. Like if I ask you how much is I to the 20, because 20 is even, can be divided by 4, you would call it 1. If I ask you I to the 22nd, you would say because it cannot be divided by 4, 22 divided by 4 is not an integer, then you will call -1, right? So let's say for even numbers it's going to be 1 or -1. For odd numbers it's going to be I or -I. And the same thing, if the number can be divided, not divided, if you can write something like this, I to the 17, I to the 7, it's simple, right? It's the same as I to the 4 times I cubed. I cubed was well defined as -1, and I to the 4 is 1, so the answer is going to be -I. And if you have something like I to the, let's say, 15, this will be what? I to the 12 times I cube again, and it's going to be -I, and so on and so forth. You practice, look at that section. What we're going to do now here is solve this problem. And the way we solve this problem, well, the purpose will be just to get rid of these two fellows here in the denominator and write it in this form. And how we do that, the first thing we do is we multiply this expression by two terms like these, but with this different sign, the same two terms with a different sign. This is positive, it's going to be minus. It's like rationalizing the denominator, except that instead of using square roots, we're using actually the same type of number. And like in rationalizing the denominator, if you remember in that case, when it's the square root of something, it's always going to be this fellow square minus this one square. That's rationalizing the denominator. In complex numbers, it's always going to be, and this is a trick, it's always going to be this one square plus the coefficient of I square. So I can tell you right now that the answer to the denominator here, when I multiply these two, is going to be what? 9 squared is 81, plus 1 squared is 1, is going to be 82. Aha, you don't believe me? Let's do it. Here we go. Okay, let me see this right. Yeah, 9 plus I times 9 minus I. Then we apply FOIL. 9 times 9 is 81. 9 times -I is going to be -9i. I times 1 is going to be +9i. I times -I is going to be minus I squared. And look, these two cancel. They disappear. And what we have here is going to be 81 minus I squared. But if you remember, I squared I told you is -1. So this is actually what? 81 minus -1, right? And minus is going to be plus, so this is going to be 81 plus 1 is 82, like I told you a moment ago. It's going to be 9 squared plus the coefficient of this fellow square. So 9 squared is 81 plus 1 squared is 1. 81 plus 1 is 82. Aha, we got it. Now let's go to the next one. Yeah, I'm sure you're going to start hating me laughing like that. Okay. Sounds like a hyena, but yeah, it's okay. It's okay. At least we see that there's animals and something alive here. Me. Okay, let's keep going. 5 times 9 is 5 times 9. $45. I get distracted by the music. Actually, that's Atomic Rooster, just in case. Then 5 times I is -5i. 6 times 9 is -54. And 6 times I is going to be positive 6i squared. Yeah, I shouldn't put that music, distracted me too much. Okay, so here we go. Now we add numbers, can be, term lights, like 5i and 54i. This is going to be what? 45 minus 59i plus 6i squared. But this I squared, you remember, is -1. So this actually will be 45 minus 59i minus 6. So 45 minus 6 is going to be 39 minus 59i. And voila, we're done. We already found the product of these two and the product of these two. So to solve the to finish the problem, we have that 5 minus 6i can be written, divided by 9 plus I, can be written as 39 minus 59i divided by 82. Yeah, well, not yet, because the problem says write it in the real part and this complex part, right? This is how you write complex numbers. This part is the real part, and this one is called the imaginary part, or the complex part, because the whole thing is a complex number, so this is going to be the imaginary part. This b is always going to be a real number, but the I is the one telling you it's a complex number. So the way we should rewrite this one is we divide these two fellows by 82. Oh, sorry, that's not the right one. Let me go back. Okay, so we're going to divide this 39 divided by 82 minus 59 divided by 82i, and that is the answer. This actually is one of the problems from the homework. Let me tell you which one it is. They're not homework, review. Oh, problem 16. There we got it, and the answer is B. Okay guys, I will see you for the next video. I hope you're not getting bored and angry, but listen to me doing this video. This is only trying to help you guys a little bit. And okay, remember, stay healthy and safe, social distancing, and try to learn a lot and read a book or something. Take care, guys. Next time. Bye-bye.